Recording. Okay, hello, welcome all to the next webinar on the series of webinars about what's new in Advanced Design 2022 and Power Packs. In today's presentation, I'm going to give an overview of what's coming in the latest version of Advanced Design when it comes to the reinforcement design, especially when using design modules. So that's the goal of today's meeting. Okay. As I said, it's a third webinar in the series of this week. Tomorrow is the next one dedicated to what's new in Power Pack for Revit and Power Pack for Advanced Steel. While on Friday, there's a webinar dedicated to what's new in Rebar detailing tools on Power Pack for Revit, on Revit. Maybe, but to start with just a few words about me. My name is Mateusz Budziński. I'm a technical manager for software in Greatech. I'm in the AC industry more than 20 years. I started my work at Robobot as a support engineer for robot software. Next, I moved to the R&D part, taking part of the structural design software. So for the last 7 years, I've been working with Greatech on structural software development. And now I'm a product technical manager for the structural Greatech software, mainly advanced design at Greatech and innovation. So that's all about me. And now we can focus on the presentation. This is a presentation plan for today, and also a quick summary of novelties related to advanced design modules of advanced design, especially concrete modules. So I will show you today, I will start with Rc Slab Module. Next, I will focus on other general improvements to all modules related to daily work, to workflow, and drawings. And at the end, I will go one by one through modules, showing what's new on them. I will start with the slab module. If someone of you has attended to the webinar on Monday, when I showed what's new in general in advanced design, so I will repeat that small part related to slab modules, because it's a really nice and new big novelty on that version. So Rc Slab Module. We can open concrete slab with the new Rc Slab Module in advanced design environment. If someone uses Revit and our tools to detailing, knows that the slab module exists on the Revit environment. But with this version, we expand it, we provide new options, new workflows, and it works on advanced design, on top of advanced design. What for is that module? It allows us for generating the reinforcement based on the theoretical reinforcement, but also we can calculate the theoretical reinforcement using the strip method. It works on advanced design. How it works, I will show you in live just in a few minutes. So just before that, few slides. So we import the geometry of the slab to the module from the finite element model from advanced design. The process on transferring data is the same as for the rest of the module's elements, like for columns or RC beams. So when you open the slab in the Rc Slab module, the geometry of the slab and supporting system of beams, columns, walls is the same as is modeled on the 3D model. However, as the analytical model on finite element calculations, due to some simplifications, may be slightly different from the real geometry, Rc Slab provides several options to adjust the geometrical model. We can adjust manually, automatically. I will show you later. Okay. There are in fact two working scenarios. The first method is to calculate the theoretical reinforcement in advanced design and then import it to the slab module. So then on slab module, we can generate real reinforcement cage and documentation like drawings, for example. On that scenario, the real reinforcement we can define either manually or automatically. So we can define zones manually separately for both directions, on the top and on the bottom also, choosing diameter and spacing, and we can check the required area, the required minus the defined area. So we can check the delta value, what is missing when we add some our zones. At the end, of course, we get the 3D reinforcement cage of reinforcement. What next? That maybe not next. When we are preparing the reinforcement, the real reinforcement, we had a lot of new options related to the previous version that was available on Revit. So I will show some of that options, and at the end of the process, of course, we've got drawings. So the main output are drawings. Can be modified as for other Rc modules, so can be also sent to CAD software as R and DWG format. Of course, we can also generate reinforcement schedules. Drawings can be for bars and also for fabrics. At the end, it's possible to generate design reports for a slab with basic information about the geometry, materials, reinforcement parameters. In case of when we use fabrics, we can get also plans of cut meshes. Okay, as I said, there are two main scenarios. So the first scenario was to take the theoretical reinforcement calculated on advanced design, but there is also another scenario. We can stop calculations on advanced design on the finite element part and import just finite element results on some bending moments, for example, to the slab module, and then calculate, do the calculation of the theoretical reinforcement using the strip method. Next steps are, in fact, the same as on the first scenario. The strip method is used to get the theoretical reinforcement based on internal forces. So it's a multi-step method. So we start with the finite element results. Then we divide a slab into a number of virtual strips. Strips can be defined manually or automatically. And then internal forces in strips are integrated, and we get force diagram along the strip axis. Then we got the theoretical reinforcement for each strip, and of course the real reinforcement. And finally, as in the first scenario, we get bottom and top reinforcement by using bars or meshes, of course drawings, also reports, including special reports for strips. That's the general workflow. And now I will try to show you quickly how it works in reality. So this is an advanced design model, a very simple model. So I will calculate, I open the calculated model, in fact, and I select one of the slab. What next? Next, the workflow is the same as for columns, beams, or footings. So either by using the tab on the pilot called the design tab, I can select the plate, or by selecting it from the right click menu, I can open the design module. So now the geometry is sent to the module. As you can see, it's a 3D geometry. We can see beams, columns, and a slab. I said before that the geometry of the slab on the finite element for the finite element calculations could be different than in the reality. For example, when we look from the top, usually we define columns on the structural axis grid, and slab is modeled to the edge. The edge of the slab is modeled on the for the thermal calculations as to the middle of the axis of the column on its beams. That's why on the RCB module we have several options to adjust the physical contour of the slab. So I can say, okay, I want that the slab edge is identical as on the model. So you see that the green line, it's the line for the theoretical line of the analytical model, but I can say, okay, I want to expand it to the supports. So now the physical geometry of the slab is bigger. Of course, the results are only on the analytical area, but thanks to this, I can get the real length of bars, as the geometry can be adjusted according to the real geometry. Of course, I can move also a little bit columns, beams. There are some tools on the slab module. But what next? I said there are two methods, two scenarios, and we can select the scenarios using the list on the right side. So reinforcement method can be frame-based or strips-based. So I will start with that frame-based. It means that for calculation, I need the theoretical reinforcement calculated earlier on advanced design. And it's the case there. So I can check what are the results of theoretical reinforcement in X and Y directions for top and bottom. So it's a top on X, top on Y direction, maybe bottom I will select. Yes, so the same for both directions. And then, yes, there are theoretical reinforcement areas. What can I do? How can I get the real reinforcement? I said before that there are two methods, in fact, automatic and manual definition of zones. So automatic is easy, let's say. So I can go to the design settings. Oh no, not design settings, sorry. To the reinforcement settings. I can say, okay, I want to use the automatic solution, and I want to reinforce that slab using bars. And the question is how many density layers I want to use. If I will say, okay, I want to use only one layer, but no more than 70% of the required area. What does it mean? It means that if I calculate that slab using that settings, we will select a better view. I get the automatically generated bottom on top reinforcement on the whole area using the maximum value of the 70% of the maximum reinforcement that is on the slab. To see it a bit better, maybe I will change the displaying results to the delta. So again, this is the map with the required reinforcement area. So it's 286 in the middle of some part of the slab required for the bottom reinforcement. As the real reinforcement is 251 by using that automatically generated zone. So the delta, so the missing reinforcement is only on some areas, not too much. So I can use also manual method of defining zones. For example, adjusting for adding additional zone, additional layer of reinforcement. So I quickly add some, really quickly, we're not going too much into details. So I added a zone with using, yes, you cannot see too much the difference because the mesh is dense, let's say so. But anyway, when I can easily change the reinforcement spacing, diameters, and add additional layer, additional part of bars somewhere inside. Of course, I could do this the same using the automatic selection of 2 layers. So, for example, by default, 70% is covered by the first layer, and the next 30% for the additional bars. So when I do the calculations, I can see that by layer. Okay, it's a bottom and top. Maybe I'll use another view just to you can see better the reinforcement. So you see, this is a top reinforcement. I can select the bottom reinforcement. Maybe the diameters are different than before, but it's the method we can get the reinforcement automatically. Of course, it's not the end of the work, because the next step, I will not show you because we have no time today for showing all options, because there are a lot of nice options related to defining reinforcement. For example, if you want to define hooks or not, what are the rules, what are the diameters I want to use, what are the increment spacings, and so on and so on. So there are some defaults, there are some rules, and finally I get the reinforcement cage. Of course, I can change the colors. Maybe I'll select the bars according to the family. A little bit different. I hope it's better. But anyway, the output, the final output, are drawings. So I can select the drawings tab, get the 2D views of the bottom, or I zoom it, on the top reinforcement. In both cases, I have some default schedules. Of course, I can change schedules. I can select totally different. I can update them. So it's the same workflow as for the other RC modules, and the same for drawings. I can do some changes. Sometimes, as on this case, we see that using that scale, it's maybe not best view for that reinforcement, or even that scale is, maybe I'll move a little bit the view. I can do some adjustments, move on descriptions, add dimension lines, and so on. And at the end, I can, of course, there are more options. At the end, I can, of course, save these drawings using the DWG format. So then I can use it on AutoCAD or other software to detail more, to add more info if I want. So that's the basic scenario using the existing reinforcement area from the advanced design. But I said that there is also another scenario using the strip method. What's the difference? The difference is that when we start work, so after we import the geometry, we've got also the internal forces imported. So for, well, I don't know, I can select any load combination. I can display forces, maybe bending moments. So there are a lot of displaying options. I will not show them now. And now I can, having the values of the bending moments, I can calculate the theoretical reinforcement first. I can use the strip. I can use definition of strips made by me manually. So I just, by using lines, we can add strips. So the strip is as you can see, it's maybe different bending moment. So we can define strips. We can adjust strips the width, because the values of the diagrams is according to the internal forces that are integrated through the special sections along the strip. Maybe I will show that. I will show also sections. Yes. So you see the values from the sections. Okay, we have a full possibility to change the density of sections. So anyway, at the end, I have a strip with integrated forces. Of course, I can add the strips manually over the columns, over the beams, but also I have a possibility to generate strips automatically. So strips are generated in both the perpendicular directions. You should note that the strip method is usually helpful for the case when we have a regular layout of beams, columns. So we have strips. So strips are used for integrating forces. What next? Next, of course, is the process of calculation of reinforcement. So I can run calculations and then check results per strip or for the whole slab. So yes, there's a slab. You can see diagrams for strips. So I selected one of, and we can see that the blue is the vertical reinforcement area along the strip, and the red is the real reinforcement, because we've got automatically zones, reinforcement zones, and the reinforcement over whole slab on the top and the bottom in both directions. So again, you can generate drawings. So the workflow is the same. Next steps. So in short, that's the new Rc Slab Module that can work on top of advanced design. So I will go back to the presentation. Okay. Yes. What's next? General improvements to all Rc modules. I will start with several improvements related to daily work. First, again, I will start with PowerPoint, and then I will switch the application to show how it works. So the first improvements is related to opening the Rebar Dialog after double click of a rebar. So it's an easy way to get info about bars or to change bars. So now we can double click on the bar in the 3D view to get the dedicated tab opened with the reinforcement edit dialog. Another improvement is related to visibility. Now we can really easy way to select what kind of bars are displayed or not. That there is a dialog for selections types of bars that are visible. So just improvement to work with bars. Next improvement is related to reinforcement restorations. What does it mean? When we have a reinforcement calculated or modeled, we can then this reinforcement restore after is gone. When it's gone. When I define the model and when I define the reinforcement, and then I want to use this reinforcement that was calculated or modeled by me, but for other data, then usually when I change some data, the reinforcement cache is removed automatically. So it's an easy way to get it back. It will be clear when I show you just in 1 minute. So only one slide left me related to the improvements to daily work. So the last thing related to this is that, yes, with that version, multiple windows in all modules have been modified to maintain the uniform appearance, size, layout, and the data input. So improvements include many dialogues, as beam reinforcement settings, display settings, report settings, and so on. So how it works in reality. So I will open the standalone module this time. It's a beam module. I selected some example just to not start it with empty model. What I should start with, yes, I said that when I click on any reinforcement, the dialog is open. So yes, we'll try. So I click on the bars, and yes, I click on the package, one of the bar of the transversal reinforcement bar. So the dialog is open on that tab of the dialog. Again, top longitudinal bar layer, so I can easily check what is the diameter. Of course, I can check it also using the viewer, because when I hover the mouse over the reinforcement, the tooltip is showed, so I can easily find out what is the bar mark diameter, what is the kind of the reinforcement. But by double click, I can easily modify something. What next? Next improvement was related to, I forgot, yes, to visibility. Yes, I have a beam, and there updated new dialog for display settings. So I can, for example, change the coloring bars by diameter, or maybe I will, in an easy way, select what kind of bars I want to see. So I can say, okay, I don't want to see top and bottom bars, or even transversal bars. So the other bars just left. So you can see it's now easier to see in details some areas if I want. Yes, dialogues. When it comes to dialogues, I said that they are improved. Maybe it's not a big thing, but you know that when you open reinforcement assumption dialog for beams, the content is changed, but dialog is changed. So the content, in fact, is the same, but the layout is different. But also we merged some other dialogues of, I don't know, bar splitting, bar constraints dialogs are now on one tree, on one dialog, reinforcement assumption dialog. Okay. Again, I switch to the PowerPoint. Yes, I forgot, sorry, because I said that there is an option, the new option that is called restore reinforcement. How it works, maybe I will show you on the new simple model. So imagine we have a beam. I calculate the reinforcement, so it's a, yes, my fault, because I didn't change the settings, visibility settings. Yes, this is the reinforcement. Like the reinforcement one is displayed by family. Well, in this case, it's not a big difference. This is the reinforcement I've got. Of course, it's just example. Now I can modify this reinforcement, change bars. So imagine we have a building, and on that building we have a renovation state. So we want to see if new loads, if the existing beam can carry new loads. So we model the existing beam. So we import we enter the geometry, we enter loads, we enter everything we've got from the, let's say, initial state. We've got the reinforcement. Of course, we've got the reinforcement. I said that I add so lots. It was on the cell of weight. So I add some additional load. Yes. So this is the beam. We see that verifications are done. And now I want to see if exactly this reinforcement, because I said exactly this reinforcement, because I can edit. I can edit bars, so I can change diameters, change totally the shape of reinforcement on that beam. But when I do some changes related to data, I don't know, I change the values of forces from 10 to 15 kilonewtons per meter. So in that case, the reinforcement has gone. I don't need to redo the reinforcement from the scratch now to check if the previous reinforcement can work, how they behave, that beams with that reinforcement with new loads, because now I have a button restore reinforcement. So when I press it, the previously generated or manually created reinforcement cage is back. So now I can run the verify option. For this, when I changed from 10 to 15, I see that, unfortunately, this reinforcement on that beam is not enough for that loads. So restore reinforcement is just easy way to get back the reinforcement I've lost because of some changes. Of course, any changes, again, I restore, verify. So that's the workflow. I see that there are some questions on the chat. I will answer them at the end. Okay. Next point is related to improvements to workflows. The first one is related to import of the geometry of continuous beam to the beam modules. The point is that previously, when we have modeled the beam in advanced design using one element, there was no problem. We were able to import to the beam modules as a multi-span beam. But in case we model the beam using the single spans, only one single span can be imported. We will be able to import only one span. Now, with this version, it has been changed. So I will show you how it works. Maybe better. I will just open another example because I have small example that to show it. Yes, why not? Yes. So imagine we have a model, an advanced design. So there is a beam that is modeled by using single spans. So when I select only one span and import to the module, then only one span will be calculated. I will be able to see only reinforcement for that one single span. But for the multi-span beam, now I can create the super element. Of course, the super element we are able to create since the previous version. But now, when I do this, and when I go to after the calculation, when I go to the module, when I select that beam and open to the design module, so RC beam module, then it will be imported as a whole multi-span beam. Of course, in case we have spans with different geometry, different height of the spans, it's as possible. So you can see that that beam was important with as free spans that creates the one multi-span beam. Yes, and another improvement related to workflow is about the transfer of values from of results from advanced design to design modules. Now we can select what we want to transfer. If we want to transfer values from combinations and nonlinear analysis cases. Again, it will be better to show it on the model. So it's a model that contains some tension-only elements. So it requires to use the nonlinear calculations. And to do calculation of footings, for example, or columns, it will be better to use the results from non-linear cases. How we can do this? Not that on the application settings, on the BIM settings dialog on advanced design, there are settings related to export of loads to design modules. So in addition to settings we had before, so load import efforts from cases and import values and definitions combinations, we have also a third method, import combination values. It also applies to results from nonlinear cases. So once again, I had selected the last option there. So when I select the, I don't know, columns, beam, whatever, oh yes, it's not on the analytical model. So when I open it on the design module, internal forces will be imported. What is important is that in addition to simple cases, the definition of combination is important, and what is more important, that yes, it's not on the case. Sorry, because I have opened this footings before I show you, so that I didn't put the values from the model, but you can see now results. What is the result of import when there is not selected the last option to import non-linear cases? So I have imported just values from two basic load cases, different load. So again, sorry, it's my fault because I have this being calculated. I had this footings calculated earlier using other settings. So again, I should select footings or maybe columns. I hope this time we'll see the effect. And apologize, I think I made a mistake because I opened the module. I need to calculate it because it's non-linear. Maybe I opened the model when it was not calculated with non-linear cases. And my presentation was. So we need to wait a little bit. Okay, so again, I'm just curious. I selected the element, maybe this column this time. I will open it. You know, when we open any element to design beam columns for the first time after the frame calculation, it takes a little bit longer, more time than usually. So you can see when I open the dialog for load combinations, I see that the list of combinations now is not a list of simple load combinations from the existing basic cases, but they are non-linear combinations. Also in the internal forces tab, you can see not only results from two basic load cases, but results for each non-linear case that was calculated. So that's the method to import and to be able to calculate elements, RC elements from the model that was calculated using the non-linear cases. That's an improvement related to the workflow, in fact. And the next improvement to drawings. what kind of improvement to all drawings or for all modules are introduced with that version. So now when we generated reinforcement drawings in Rc modules, rebars are described with, by default with their position number. In the newest version of the program, it's possible to extend rebar descriptions by additional information, such as number of bars, diameter, length, or more so. I will show you again, maybe, why not, I will use this simple beam to show it. So I need to go to drawings. So I will generate drawings for that simple beam. And when we have any view, section, when we have a section or the elevation view, we are able to generate additional info. I will start maybe with bending details, so I can add bars next to the element. I can add description of bending details. Yes, annotation of bending details. Again, it's a updated dialog, so it's a little bit different than the previous versions. So it's the same view, but with additional descriptions. And I can also, what is new in that version is that I can add annotation views. Maybe I'll show you and then I will change the settings. So the settings of the annotations next to the position number. Of course, I can change settings. I don't know. I don't want to see the length value, just number of bars and diameter. Now I'm using, if I'm not wrong, French or English localization. So it depends on the country. Now I can see H6. So in some countries it's diameter 6, Phi6 symbol. So anyway, that's the new functionality related to adding annotation for bar marks. Next improvements, yes, support axis on beam elevation. So now we can show axis of supports. So again, it's just 2 clicks to show it on the beam. Maybe, but before I will do it, I will do some change. I will change the model, because to get the reinforce to the axis and names of supports, it will be nice to have a name of support. So on the geometry dialog, we have a possibility to enter the names of supports. So for in my example, it could be axis A and axis B. So then, when I go to drawings, maybe we are bending the detail. Drawings, yes, pan elevation. You can see, no, we don't see because I didn't select the option. There is a new option, show axis, and we can see. I need to move a little bit description of the bar. Symbol A and axis A, and the same on the second column. So it's a small improvement related to drawings, but I don't, just to show you that there are some changes related to our modules. Yes, in the module of the reinforcement concrete walls, as well in the new module of reinforcement concrete slabs, now it's possible to generate schedules for reinforcement fabrics. So we can add, yes, I have a wall module. So I open on an example file. I will open drawings. Yes, drawings. It's a drawing for the wall reinforced by using bars. But I said I want to show the reinforcement using the fabric. So I need to change the settings. Yes, there are fabrics. Yes, you can see there are meshes on the top and bottom side of the and the inner and outer side of the slab. So when I go to drawings, if there are drawing, there's info about the drawings. There are also additional bars. So on the drawings we can see bar schedules, but I can add it adds new option, fabric schedule. Of course, there are some settings. Now I'm using millimeter square millimeter as for the area. Maybe I need to change, but anyway, it's just an example that now we can generate schedules for fabrics. Okay. Yes, and possibility to show only one bar from the distribution. So on the wall module, I could select only one bar. So only one bar can be visible, not all necessary all bars. So it's simple option. I will not show you on live. Now time for changes for each module. For the beam module, yes, there are several new improvements. I'll start with the possibility to change the method for selecting the rear reinforcement for longitudinal bars. So now the existing settings uses the predefined number of columns of bars, and now we can consider enter number of columns as the maximum limit, and it's starting with the smallest number of bars and increasing the diameter. So the algorithm is searching for other possibilities to define the reinforcement. How it works, maybe I will show you quickly how it works. Maybe be easier to understand when I select no. So this is a sections, the millimeters units on that project. So by default, when I do the calculation, you will see, okay, there are some 4 sets of bars, but why 4, not 2 or 8? Of course, it depends on the loads, but also depends on the settings. So on the reinforcement assumption settings, there is a tab called number of bars. So by default, for the width between 270 and 370 millimeters, so with that area, by default 4 bars are generated, 4 columns of bars. What is the diameter? I don't know, 16. And on the second level there are 10. It's on some sections, of course, it's on the selected section. But anyway, how new settings works. So when I go back to the bar constraints dialog tab, there is a new option called consider number of bars and layers as maximum, with 2 sub options. So I will select the minimum number of bars. I will see what is the difference. So now, using that settings, the module used the 25 diameters with only 3 columns. I can select smallest reinforcement area and other sub options. So this time we see another set of settings. It always depends on the case. On this example, is not very visible, but sometimes, as on the PowerPoint, the selection of the minimum number of bars gives less number of bars with bigger diameter. Predefined number of columns gives the same number of columns as it was entered. And the third option, the smallest reinforcement area, try to find the smaller difference between the required and the real reinforcement. So in this case, could be something between two solutions. So we can now have options to play with. So it's not only strictly to the previously predefined number of columns, so we can now try to use other settings. And another settings is related to the configuration of multiple links. First, now it's much easier to set defaults, as layouts are now defined by using a list with pictures. And also on the reinforcement edit dialog, we can easily choose the different layout. Yes, I will show you again on the example. So on the reinforcement settings dialog, there is a settings. Maybe before I need to go to the transversal bars and change if the shape of the bars is defined automatically. I want to say, okay, I want to use multiple links. What will be the effect? I will calculate. On that example, I have one bar around all the sections, and there is also another link inside. But maybe I want to use different configuration with two the same shapes of links. So on the reinforcement assumption dialog, on the multiple links tab, there are settings. So again, by default, for 4 longitudinal bars, main bars, we have in fact 2 settings. The first one, default one, it was the first one, and I can select the second one, and we see these are different settings with 2 identical bars. Of course, depending on number of bars, the number of settings is bigger, but that's the way you can easily now select wanted settings. But also, I said that on the reinforcement edit dialog, we can change it in more easy way. So again, there is a configuration, multiple links, and I can on that stage also change this. It's also useful for that users that use reinforcement bars, generated reinforcement on Revit when we start with generation of reinforcement using that dialogs. Okay, I switch back to the PowerPoint. Other improvements related to the reinforcement, because as I said, on modules there is a lot of smaller user improvements from the left, from the right. So again, I'm showing on this picture just 4 selected. Now we can add, by using a checkbox, U-shaped anti-crack bars on the edge of the support. So you know the anti-crack bars that are only longitudinal bars on side of the beam. Now we can also add that U-shaped bars on over the supports. There is an option to change the arrangement of top bars on support, because this is the picture on the left is the one option, and on the right you can see the new option when the bars are strict in the same column as the main reinforcement. Another improvement on the right top view is the adjusting of hooks of top reinforcement. So we could automatically adjust the location of hooks of top reinforcement to avoid clashes with other bars. So bars are just moved to avoid that clashes. And another options on the picture on the bottom right, now we have a possibility to extend bottom layers of bars through the whole length of the span. So if we want avoid that bars are finished somewhere in the middle, maybe not in the middle, but somewhere in the span, we can select an option, and our bottom bars are always stretched to the columns. Yes, it was about beam. Now, few words about columns. Easy definition of transversal reinforcement. Yes, the dialog for addition of bars for transversal reinforcement has been modified. So now it's much easier to check and change the transversal reinforcement. I didn't open the current module, so now I need to open the module. So please wait a few seconds. So I'll show you in a minute. But also I will just tell you about another improvements related to columns, something similar to beams. So now there is another method for defining longitudinal bars. So we can select the current one when the minimum available diameters are used, and the number of bars is driven by the default spacing values. But also we can also select the new one when the minimum number of bars is used. So it's starting with the smallest number of bars and increasing the diameter. So on the pictures you can see for some example results of both options. And I said I will show you the difference with maybe this. There's an example, and I go to the edit Rebar Dialog, to the part related to the transversal bars. So now we can see that it's not on separate dialogues. Now it's one table. It's easy to check what is the number of packages, what are the number spacing of each in each. We can in an easy way. I don't know. I will change spacing. Yes, I changed the bottom ones. So we can see that now it changed other spacing, so it's now connected. We can also select one of default settings. So for example, if I want to use the uniform spacing for all bars, I can select the uniform distribution, that settings, set the spacing and so on. So now it's much easier to manipulate transversal bars on the columns module. I will skip this algorithm because it's just changed the result. And now time for footings. Yes, the first improvements is related to the geometry optimization, because we have now new options. So we can set the limit values for the dimensions, the maximum width, or we can also freeze the height of the footings. We can also include during the optimization, the shape optimization calculations, the eccentricity of the footing. So there are several new options related to this. How it works? I have yes, there is a simple footing, and just on the geometry dialog, we can see that there are new options to set the maximum value of the width. I don't know. I can say, okay, I want to use very small value on one direction. So when I do preliminary sizing, I had no big loads on that slab, on that module probably. But anyway, we can see that there are new options related to the preliminary sizing restrictions. And when we calculate, when we do the preliminary sizing, they are taken into account. Another improvement related to footings is the possibility for considering earth pressure for the sliding verification. So when we activate the sliding verification, now there are new checkbox, in fact, two checkboxes to consider earth pressure for the sliding, and also to consider passive pressure for sliding resistance, because there are two possible pressures. So one is the passive pressure. So you can see on the report then that the vertical part of the active pressure increase the resistance, is the same of the when we want to use the horizontal part of the passive pressure, but the vertical part of the passive pressure decrease the resistance. So anyway, at the end we have values of the sliding resistance for sliding with or without using one or both earth pressures. Another improvement is related to the multi-layer soils. So there's a new method for considering multi-layered soil for the bearing capacity. The previously available methods are based on the replacement of soil layers by a single layer with the average, with the mean values of parameters. This new method is called substitute foundation method, which is based on the solution proposed in the Polish geotechnical standard, but it's not only Polish, it's from geotechnical books also. The idea behind this method is to check the bearing capacity of each soil separately, starting from the foundation level, but then for next layer, the check is done on its top level. And for this, it's assumed that there is a fixed foundation located on the top level of this layer, with a bigger width, with other forces, and gives different stress distributions. Why and for what we are using this method? Yes, it's a good example, because on that example, I'll maybe select, I will remove that values related to default. Yes. So imagine we have a footing. Footing is on some multi-layered. We have few layers. It's a sand on the top, silt, so weak layer in the middle, and the clay on the bottom. So I want to calculate the bearing. So we see there are some results. The bearing resistance in the first line on the here 56%, but by default, probably by default, when you go to the designed assumptions on the bearing verifications, multi-layered soil verification, it's not activated any method for multi-layered soil verifications. It means that the verification was done only under the foundation, only on that sand level. So for that sand level, sand layer, we have bearing resistance more than 50%. So I will change this. So I will change first, maybe I will use the existing methods, the average methods. So there are two methods, as I said, the DIN method. There's a special DIN method, so I can use it, of course. But I got the message there. Maybe it's a small font you cannot see. So the friction angles of the soil layers being touched by the ground is more than is differ more than 5 degrees from the arithmetic medium. What does it mean? We need to go to the definition of our layers and see what is the what is the friction angle of each layer. So the middle one is 24, the top one is 36, so there are big differences. And that method, DIN method, German method, is only valid for when the difference is not too big. We can try, of course, we can try use the option that is called allow reducing friction angles. What does it mean? It makes some of layers weaker just to the calculations can be done for the multi-layer. So in this case, the sand layer was for calculation taken as a weaker with the smaller value on the friction angle. At the effect, you see that the bearing resistance is 98%. Is it correct? In this case, maybe Of course, I can also use the average constant method, other average method, but either din or average method, they are average methods. So I can use the new method. That's the last one selection. Consider substitute foundation method. Of course, I can do the calculations. I see the 56% of the ratio for the bearing resistance. And in this case, the question was why, when I select the German method, the resistance was 98. It was because the difference, that middle layer was very weak, sealed. So using this method, the results are more reliable, more accurate. So especially for cases when we have many layers and some weak layers, using that substitute foundation method is better. Okay. And yes, it's something for Poland. A new DA2 star entry has been added to the list of available design approaches for bearing capacity according to Eurocode 7. So it's mandatory for Poland. So I will not go too much into details, but for guys from Poland, we know what does it mean. And the last module, just a few words about the wall module. Maybe I will not show you in the live presentation, just a few words. Set of new options for reinforcement of Rc walls modules that are available on that version, including you can now decide which bars, vertical or horizontal, are closer to the wall face. We can choose where the transversal bars are generated. So we have a lot of new options related to the transversal bar, the small bars that keeping both layers. We can decide if you want to extend horizontal bars inside a node. Of course, it's a case when we have a group of walls, for example, 2 walls, and there is a node. And if the longitudinal bars are extended into the node, so that's a new option. Or for small cases, in the case the default bending diameter of transversal bars is too small, it can be automatically adjusted to correctly cover the longitudinal bars with bigger diameters. So there are examples of small options on the left, on the right, related to reinforcement generation for walls. There are also other improvements to edit dialogues for walls. So we can define bar distribution using spacing of bars. We can define with edit density of transversal bars, define offset for transversal bars. We can, yes, so there are many smaller options that allows us to adjust the reinforcement on the wall in a better way. Oh yes, that's all. In fact, that's all. I also expected to have a webinar during 1 hour, so 1 hour 10 minutes, so slightly longer. The full list of improvements and new options is available on the What's New document. Of course, you can download it from the Greatech Advantage website. Because as I said, there are many smaller improvements on the right and the left, so I think it's worth to take a while and check that document. Even si long, you can just scroll it. And as I said before, there are some questions on the chat, so I try to read them. Oh yes, it's question related to snaps. Snaps on beams, no, not beams, on planar elements modules. I have one. By the way, in that version, there are some improvements related to snaps on zones. So you see that snaps. I don't know if it's the case, the problem. I hope, I think it was question related to slab module when we have zones and snaps with zones. On that version, it was improved. I know that there were changes. I don't know if it's the question from the related questions. Another question is, do consider continuous beams to ensure that they are detailed as when we have a continuous beam and there are many columns, of course, the geometry of the columns is imported through the as it was modeled on the FEM model. So if I have a multi-span beam and it was imported from advanced design, the location of beams of columns is driven by the model from the FEM. Sometimes, but by the way, on the next version is planned to possibly to move a little bit the geometry of the columns that is imported, similar as for slabs when the geometry of the column is slightly different, the real geometry is slightly different than the geometry on the FEM model. But when we model the beam on the standalone module, yes, we have a full control, I think. It was another question related to axis of beams. So it's a question if that axis drawings is always on the center of supports. Yes, on the current version, it's always on the support of the axis. It's defined automatically on the axis of the support, but helpfully on drawings we can move it. On drawings, of course, it's not automatically, but we can get what we want. Of course, if we want add, I don't know, dimension lines, and the second one from the element to the slab, yes. So we can adjust drawings with that options. Another question from the chat. The webinar is recorded, so I hope it will be available for downloading somewhere on the other Creative Advantage probably site. Yes, and was the question related to RC footings. Is the algorithm searches for the weakest layer of ground profile or just one layer below? So as I said before, to the depth, because the methods they are available, either German DIN or also that substitute foundation method works to the depths two times the width of the footing. So if there is 1 meter length width of the footings, so we are checking solid layers that are to the depth equal to 2 times the depth. Then we check all layers that depth. So by the way, on the method that is called mean solid parameters for average for constant depths, we can specify that depth. So again, all layers are checked on that area, but only when we consider multi-layer soil verification. If none of that checkbox is selected, the verification is only done on that foundation level, so only on that for that layer just located below the foundation. Okay, and there is a new question. Yes, it's Mr. Murray. Again, ask about the snap. So maybe it will be better to contact technical support team to make a, let's say, short presentation or explain the problem with them. So yes, I ask for this. And when it comes to the presentation, that's all. That's all from my side. Of course, if you have other questions, again, if there are some technical questions, it's better to ask to contact phone or by email our technical support teams. On each country, we have a Gretec office. Of course, you can also contact me personally by, you can find on the websites emails to me, so Mateusz Budziński at gretec.com. So thank you for watching this webinar. I hope you know now more. And again, more details you can find on the What's New document. Thank you and goodbye.